Today I want to show you how to automate the process of implementing business logic. What I mean by that is custom logic that you have to insert into your code depending on rules that your business operates with. For example, here's a simple function I let GPT make up. It's a function that assesses credit risk, and depending on some logic, depending on a few variables and some thresholds, it assesses the credit risk according to what this fictitious business deems as a rejection reason for a credit, or as a high credit risk, medium high credit risk, and so on. And depending on what kind of industry you're working in, you have seen similar code or similar logic that you had to implement for the business you're working for. And as you've seen in my code example, there are a lot of thresholds that are just hard-coded inside of my script here. And the problem with that is that when at some point the business decides to do things a little bit differently or to run with some other configurations, then you will have to go into the code and fix things, or rather adjust things. It's not really broken, it just has to be different. And this can become a huge bottleneck really fast. But in today's video, I want to show you how to create a framework so that business users can set this up without you needing to intervene. I'm thinking about an app where business users could just log in and check a variable, say if this thing is less than some value, let's put in 600, they could throw this in, assemble business rules that way, and then save them for you as some name. Let's just stick in something in here, and then they could save this rule, and what you would automatically generate from that is a YAML file that you could load inside of your application. So in today's video, we'll take a technical deep dive into functional programming that makes such configurations possible. So buckle up and let's dive in. Alright, so let's start simple and have another look at this credit risk function that we're working with here. Again, the numbers are made up, but I think the logic is kind of instructive. Here, what we have in this function is a function that depends on a couple of arguments, and then we have a simple case when that just goes through different conditionals and then says risk needs to be rejected, the risk is high, medium, high, and so on. And then this function will return a list with the risk level and the decision that will automatically be generated depending on this risk level. And also it will tell you what the credit score was. So what we could do is to execute this function here with a couple of test arguments. And then if we do that, and if I do that so that the output is shown, then you see that, okay, for this specification here, we have a medium risk level and the decision is to approve this thing. If I were to lower my credit score, say to 500, then we'd see that the risk level immediately becomes reject and the decision is to deny. So that's the kind of function we want to use as a dummy example here to figure out how to automate this conditional logic via configurations that a user will set for you without you having to implement these hard-coded things here. And in order for us to do that, let's start out very simple. Here in my script, I have created two functions that do very basic things on numbers. This is even function checks whether a number is even, and is positive checks whether a number is positive. And what we could do is to take the is even function and stick in numbers from, say, -2 to 4. And then, of course, I have to execute this whole script in order for things to be seen. And now we see that, okay, this checks now if things are even, and we see that every other value here is true and the others are false. And for is positive, we could do the exact same thing. Let's do from -2 to 2 or to 3. And then we see that, okay, for these positive numbers we'll get true back and for the others we'll get false back. So we have very simple functions that just check a condition. Now what I want to show you here is a nice way of how to combine simple conditions, because this will be our building block later on to let users create conditions and then mix and match them according to what the business needs. So kind of what I want to do is to check, for example, if something is even and positive. What we could do, of course, is to take this is even and match this with is positive. And then if we take the same amount of numbers here, then we see that, okay, now things were matched. We see that only the positive numbers, this must be 4 and this must be 2, will be indicated as true, and all the other ones are false. Possibly you can see this better if we take a look at the numbers here. So for these numbers, we have that only this one and this one is even and positive. So this is already a nice way to combine logic. But this still requires me to put in the inputs manually, and you can see here that I have to duplicate the stuff. If business logic becomes more involved, then I have to call this assembled function over and over. It would be nice if I could just take something like is even and say combine this with is positive. But if I execute this part here, we see that, okay, operations are only possible for numeric, logicals, or complex types. What I want to be able to do here is to create a new function, say is even and positive, and save this. But again, as we've just seen, this isn't possible right now. But there is a way we can make this work, and this brings us to a bit of functional programming and object orientation as well. You see, what we can do is to overload this AND operator for specific things. And how this operator behaves will depend on the class of things you try to work with using the operator. Let me, for this demo, show you what this means. If we take, for example, the class function and stick in a number 2, then you'll see that a number 2 is of class numeric. It's kind of obvious, but that's what we have here. But the interesting thing is that if we take our function here is positive and stick this into the class function, we'll see that the class of that is a function. So what we might want to do is to overload this operator to behave differently with things of class function so that this kind of operation becomes possible. Unfortunately, we cannot do that, but what we can do instead is to assign another class to a function. So let's create a function that we call asPred, which means as predicate. And here this is a function that takes as an argument a function that we'll call f, and what it returns is something that we construct using the structure function. You'll see in a second what this does. And it will just stick in the function and say the class of this is the vector pred as a predicate and all the things that it initially had. So if we were to just take this stuff here, for example, and stick the is even function into this, then you'd see that this part here is just the function that we had before combined with this pred attribute that we have in here, or that we manually put in there. And then this structure thing does nothing but create a function. This is still just a regular function, the one that we've had before, but it also says that the attribute class has the prediction and the function now. So that might seem really confusing right now. And also you might wonder what's the point of this, but it will become clear in a second. Just bear with me here. So what our asPred function does is to do this wrapping for us for arbitrary functions. So let's move this to the top. And then what we can do with this function is to wrap our function into this. So let's do this here and let's do this there. And now if we call this stuff, we see that, okay, is even is just the function that I had before, now with this additional class attribute. And fundamentally, this doesn't change any behavior yet. We can still do our function call like we did before. We can still do that with is positive as well. We can still combine these things with the AND operator as we did before, because, well, these things just return the trues and falses, so the AND operator knows how to deal with it. And what's more, we still can do what I want to do here. So if I do this, it will still tell me it doesn't know how to deal with that. So now comes the cool part. We can say that the AND operator should behave in a specific way with things that have this class attribute that we've specified here. And the way to do so is to use these backticks and say that this operator, which is the AND operator, should behave in a specific way for things of class prediction. That's where this dot comes in. So with this notation, we can specify a function that is supposed to define the behavior that will happen when you use this AND operator with two things. You see, the AND operator is always used with this one thing that is on the left hand side and the other thing that is on the right hand side of this operator. So what we can do here is say the left thing and the right thing, let's call it E1 and E2. And now this function will determine the behavior of what this AND thing is supposed to do. So what we say here is that this function will return another function that will just have all of the arguments that the initial thing had, and there it will just combine this left hand side thing with all its arguments using the AND operator, with the right-hand side operator using all of the arguments from before. And because we want to make sure that what we return later on is also a prediction, we use our spread function to create something that returns a predicate. So if we execute this thing here now, and then check what we get here, we see that this doesn't throw an error anymore, and it just returns what we have specified in here. So it just is this function body here. It is kind of annoying that in the output we don't really see our function logic from the function that we initially specified, but it is nice that it works. You see, what we can do now here is to throw in the numbers that we have had before. And then it will say, okay, I couldn't find the function because we have to source this first. And now you see we get the exact same output as this. So we execute this part here. We see that this output is exactly the same as this output. So that's really cool. We now have a way to compose functions using AND operators with other kind of predicate functions. So what we could do now is to repeat the exact same thing as before, but with the OR operator. So let's stick in the OR operator here and use it here as well. This will overload the OR operator. And now what we can do is create a new function that is called is even or positive, and then use the OR operator. And now this doesn't throw an error and works as well. And then if we do that, we can also first check what this would give us normally. Let's throw in the OR operator. It would give us this stuff. Basically everything is true, but this -1 thing. So if we compare this with the numbers, this -1 isn't even or positive. And if we stick this into a new composed function now, we see that we don't get the same result. And here I've been shocked for a short second, but of course I forgot to change the AND to an OR. And now things look exactly the way we want it to. So this now looks exactly like our target value here. Ooh, crisis averted. This actually works the way I wanted to. There was just a little typo in there. And in a very similar way, we could also overload the exclamation mark operator. So if we stick this in here, we can use this exclamation mark in here. And now what we have to change here is to not make this dependent, this function, on two operators, because this negation operator works only on one thing. See, if you do exclamation mark false, you'll get true. And if you get exclamation mark true, you'll get false. And this is only one thing that you work with in combination with this operator. So it doesn't make sense to say here we need two arguments. So let's just call this one argument and we call it X. And here now we can just stick in the regular operator. And now that we have overloaded this, we could take this output. And if we were to negate this regularly, so this is just the output here, we were to negate this, what we get, it's this stuff. That's the one we're going for here. And now let's create a function by composition. Let's do is not even or positive. And then let's do not this stuff. Or actually, let's just go with not is even or positive here. So that's our function. And now we can call this using our numbers from before. So let's stick this in here. I have parentheses too many. So now we get this output, and this should be exactly what we have here. And indeed, this is the case. So with that, we now have a basic understanding how these operators work and how we can specify that they should behave differently depending on what they work with, namely a thing of class spread. But now I do want to make things a little bit more general. You see, if I were to try to create a function that is called is larger than and make this depending on some threshold, then we don't have the tools for that yet. And in order for this to work, we need basically a generator of these predicate functions. So instead of having is even and is positive as this as spread immediately, what we want to have is to wrap another function layer around that. So what we can do is let's do is larger than, and let's say that this is a function that takes a threshold, and this function returns a predicate, so as spread, a function x, where it just checks if x is larger than the threshold of this function that we've specified in the outer layer of this. So this is what it's supposed to return. You know what? Let me move this down here so that we have more space. Now what we could do is to call this with an argument. Let's call this larger than 50. And then we execute. We see that we as an output have another function that checks our threshold. And we could call this GT50 as in greater than. Technically I should align the names here, but whatever, let's just go with this here. And then we could do greater than 50 and throw in numbers that are around 50. So let's do 49 to 50. These are the numbers we're going to check now. And with this GT50 function now, we see that, nice, this works. It returns true as soon as this thing is larger than 50. But there is one technical detail we have to watch out here. And honestly, if you don't know about it, it's really easy to make the mistake that I'm going to show you next. So for example, let's create a variable called threshold, and let's say the threshold is 50. And then let's create this GT50 function depending on this variable called threshold. And now before we for the first time use this new function, let's overwrite the threshold value to say, I don't know, 40. So if we execute this stuff here, you would think that this threshold inside of this GT50 function is still the number 50 because we have called it when threshold was 50. But if we actually check our result here, we see that everything is now true. And the reason why this happens can be seen when we go down to numbers lower than 40. You see it returns first 39 as false, then 40 as false as well, and with 41 it is then using this as a threshold where we have this threshold 40. So for some reason, even though we have specified this function before, it was still affected by the fact that we changed this threshold variable later on. This has to do with how R uses lazy evaluation, and there's an easy way to fix that. But you just have to know about it. This is why I've said it's really easy to run into this problem when you don't know about it, because, well, it's just you don't think about this lazy evaluation stuff. So the way to fix that is to just use the force function to say force the evaluation of this threshold variable inside of this function here. So now if we do that, we are in the exact same setting as before, having defined a threshold variable, created our function that checks whether it is larger than 50, then change the threshold variable. And now if we call this function, we see that we actually get false all the way until we are at number 51. So if we do go back to numbers 49 to 51, we see that 49 and 50 are given as false because they are not greater than 50, but 51 is greater than 50. So when you create a function that returns these predicates for you, make sure to also force the evaluation of the arguments that you use inside of your outer function. That's always a good defensive mechanism to just throw in this force function in there. Okay, cool. So now we have understood how to work with these predicates and also how to generate them for us depending on some other variable. But we're still not there where we can recreate our business logic using this credit risk with the logic we have learned about so far. You see, if we go into our function like before, we see that there are lots of variables involved, and so far we haven't really talked about how to deal with lots of different variables here. So let's do that next. By the way, if you enjoyed this video, make sure to give it a thumbs up so that I know that you like it and the YouTube algorithm also knows that you enjoy this kind of content. It really helps me a lot, so thank you for that. And also, if you want to learn more about R, I do have a free PDF guide that you can download, as I've said, for free. You can do so by checking out the link in the description. And now let's get back to the video. And to do so, let's clean up our examples from before. Let's remove this stuff here. Let's get rid of these easy examples that we had before. Here's our overloading. And for now, let's get rid of these easy things. But what we still want is to talk about our as_spread function. What I want to do here is to throw in two things. One, as a safety mechanism, if something is already a prediction, it just returns the function as is. So if inherits of f contains already the prediction, then just return the function that you got, or rather the predicate that you got. So that's one safety mechanism to not layer these class attributes. And now that we have that, what I also want is to specify an argument name attribute. So what I can do here inside of my structure is to specify next to the class something that I call argname. And here I want to make this dependent on a variable. Let's call it argname. And this variable is used as part of our asPredicate function. Actually, let's make this the other way around. Let's say the argument name is by default null, and let's make it the second argument here. And now that we have this function, what I want to do is to create a helper function that can really easily combine a variable name with some testing function. The testing function is supposed to be rather generic. So let's call this spread1 because we want to work with one argument only. And let's make this a function that depends on the arg name and the function that tests some logic. Let's call it test function. And this function will be a generator of predicates. And as we've just learned a couple of minutes ago, it's a good idea to force the evaluation of arguments. As the first step, we force the argument name. And as the second step, we force the test function. So that way things are always evaluated. Sweet. Now what this thing is supposed to return is a prediction. So let's use our spread function. And just like we had before, we stick in a function that will just pass on all its arguments. And we also want to fill the argument name with the argument name that we have in here. So the one that I want to specify with this prediction variable. And now what I can do is to grab all of the arguments as a list via this ... operator. And now the first thing is that I want to make sure that when I specify this predicate dependent on some argument variable, I want to make sure that it is also contained in the things that are passed to our function. So let's throw in an if condition and check whether either there are no argument names or the specified argument name is not part of the argument names that are provided. If that is the case, then we want to stop the execution. So throw an error using the stop function, and then we throw in an error message that will say, okay, the argument of the argument name that you specified cannot be found in the provided argument that you call this predicate with. So that's a safety mechanism and should only be triggered when the argument that we're actually looking for is missing. And now what we can do is to, once this if condition doesn't trigger, we can actually use this testfn function and apply it using the arguments. And of that, we only want to grab the one of the specified argument name. So that's our little helper function that has some safety mechanism built into this. So if we execute this, see that we have everything. Actually, let's execute everything in here. And now what I can do with this spread1 function is to create another function that is similar to the is larger than function that we created earlier. So let's call this larger than LT function, which is a function of an argument name and a threshold. And then because this will generate these predicates for us again, let's force everything to force arg name, force threshold, and then use our actual pred1 function to check the arg name. So as a predicate for the arg name, and then as a function, do a generic function that tests logic. In this case, the logic behind this LT function is less than. I think I said larger than before, but I really meant less than, or I wanted to do less than here. Let's do x is less than threshold. And similarly, we could do larger than or equal by using a different function name, and inside of the test function using an equal sign as well. And then we can repeat the exact same thing as before using greater than and greater equal than, or greater than equal. So let's do greater here and let's do greater there. And now we have a very simple set of function generators or predicate generators with arbitrary thresholds. And now we really have everything we need to generate business logic for us. For example, if we look into the demo function here again, into this credit risk function, we see that, okay, the highest risk, so this reject risk, is dependent on loan amount being larger than this number, that income ratio larger than this number, and so on, all combined with an OR operator here. The other conditions have also some other operators, but let's start simple. Let's try to recreate this business logic here. Let's call this is critical reject. That's the function name I want to use here. And now I can really translate what I have here using my functions generators that I've just created. So I want to have loan amount is greater than 100,000. So let's use the GT function and say the loan amount should be larger than the threshold value of 100,000. I can now combine this with the OR operator because it will return a predicate. And with this predicates, we've already established that the OR operator works due to the fact that we have overloaded these operators. And then let's also check the other conditions, which is also greater than. So let's throw this in here. Debt income ratio is supposed to be larger than 0.6. Or let's do credit score is less than 600. So let's do LT less than the credit score, and the threshold value for that is 600. So that's what we have here. Now, if we got rid of this, we can test our predicate. What we can do here is to throw in a list of test arguments. Let's throw this in here. And now what we can use our function with is to simply stick in these test arguments in here. And if you do that, you'll see that this doesn't work yet because our safety mechanism is triggered because we're currently passing the list and not these arguments here. So if you were to stick in these arguments as is, then you'd see that now the safety mechanism doesn't trigger and it actually checks whether all the conditions that we've specified here are met. So if we were to set the loan amount to something larger than 100,000, let's do 450,000, we check that now this critical reject condition is true. And if we have a list like this, what we can do to call this function using the list instead of sticking things in manually is to use the doCall function. So let's do call and call this with the test arguments. So with that, we've successfully recreated this business logic using our composable functions here. And if we throw in a couple of more functions to our generics here, let's throw in the function between and in set as well. Then we can do even more. For example, instead of just using isCriticalReject, we could also translate all of the other things like high risk, medium high risk, medium, low, and so on. And now that if you've already seen how this works, let me just copy in the code for you. So here we now have all of our rules, this critical reject rule, this high risk rule, medium risk rule, all composed with the correct operator that the rule needs, and also using these primitives greater than equal with the variable names and so on. And with these rules now, we can proceed exactly like we did before. What we could do is to use this doCall thing on different kind of functions like is low risk and so on. And what we could do now is to recreate this whole thing using another version of this function. And the idea is pretty much the same. You just take the function with the original arguments, assemble a list like we did before, and then you use doCall repeatedly inside of case when, and then this decision thing and the return value is copied over exactly from the initial function. So now what we could do is to apply our function using our test arguments from before. And now it will tell us that this particular setting is of medium risk and it can be approved. And in order for this to make this testing more thorough, I let GPT generate a couple of more test cases to iterate through. So let me just throw in the code in here that will just run a couple of these calculations and will put in some nice comments into the console using the CLI package, which I really enjoy. And that's why I forced GPT to use the CLI package here. And now if you execute this whole script, then you'll see a test setting using different kind of arguments, and it will check, for example, with the credit score larger than 750, is this true for our setting? And here it'll say, well, it isn't false because right now our test arguments is 720, and all the other checks are working similarly. And then it's also checking our functions by going through different kinds of overall settings. If you're interested in the code about this, you can just look into the repo I will share in the description of this video, but really it's just a bit of boring code that prints stuff to the console and runs our code, our function in different kinds of settings. Nice. So now you have a way to compose different kind of business logics using very generic little helper functions. And this is what you can use to create, say, a Shiny app to let users pick these thresholds and variable names for you. So because this video is already getting way too long, I'm just showing you the demo app once again, because I really just let GPT generate this for us because it just highlights the point I want to stress. And I don't want to make this video about Shiny in particular. The idea is pretty simple. On this user interface, users can select a variable, use an operator that we have defined before. They will translate to the functions that we have coded earlier using this GTE function or this LT function for less than. And you could say that, okay, the threshold here is supposed to be 100. We'll say that we want to add this condition. And for the loan amount, we want to have the condition greater than, I don't know, say 10,000, combine this with an AND. And we also want to have the debt income ratio equal to 10,000 and have this with an AND as well combined. And then we can call this, say, demo rule. And with this demo rule, we could now test it for a specific test user and it will tell us the demo rule here. But the really interesting thing I wanted to highlight here is that this can also generate the R code for you. And even better, you can also have a config file, like a YAML file, to have all of your specifications inside of such a config file defined. And this is something you could then load inside of your application and automate the process of changing business rules without having to touch code. So that's really what I wanted to stress here, the possibilities that you can use with this framework, even though it is kind of a bit of work to set up. I hope the ideas became clear. Let me know in the comments if there's something I missed or maybe I should elaborate some more. Also, if you enjoyed this video, make sure to give it a thumbs up and don't forget about the free PDF guide that you can check out. And now with all of that said, I say thank you for watching and I'll see you next time.